In this practical, we'll be implementing edit distance using dynamic programming. So I've already pasted here the recursive edit distance function, which was covered in lecture. However, this function is pretty slow, so we're going to rewrite it using dynamic programming. So I'm going to create a new function, edit distance, which will take two strings, x and y, and we're going to compute the edit distance between x and y. So the basic idea of dynamic programming is we're going to create a matrix that we're going to fill in with the edit distances for the substrings that we've already computed to save time, so we don't have to recompute them multiple times. So I'm going to create a matrix D, and I'm going to initialize this as an x by y array of zeros. Or sorry, an x plus 1 by y plus 1 array of zeros, because we want to start from the empty string. So this will initialize D as an x plus 1 by y plus 1 array of zeros. And now we want the first column of that array to be 0, 1, 2, 3, 4, and so on. And we want the first row similarly to be 0, 1, 2, 3, 4, and so on. So I'm going to say for I range up to the length of x. Should be x plus 1.
These are initialized this way because any prefix of, say, length x and an empty prefix, the edit distance between those two is just going to be x. So that's why we initialize the first row and the first column in that way.
Right. So now we want to step through and fill in the rest of our matrix. So I'm going to go row by row. So for each row and for each column, now we need to compute the value that will go at this location in D. And so we can get to this location either coming from the cell directly to the left, which would correspond to a skip in Y, the cell directly above, which would correspond to a skip character in X, or the character above and to the left. So if we move horizontally from the cell to the left, this would be the edit distance of this cell would be the value of the cell right to its left, so ij plus 1, plus 1, since the penalty for a skip character is 1. And similarly, we can calculate the vertical distance that would be coming from the cell above it. This would be the edit distance of the cell above it plus 1 for that skip character. And now if we come diagonally, the penalty for the edit distance depends on whether the characters match. If the two characters right here match, then the edit distance won't increase. So I can say if xi minus 1 equals yj minus 1, then the diagonal edit distance is just going to be the same as the value above and to the left. But if these characters don't match, then we have to add 1 for the penalty for that. So now we have 3 possible edit distances for this cell. We want to minimize this, so we're just going to take the minimum value for this cell. So I'm going to say min of the horizontal, vertical, and diagonal edit distance. And so we'll finish this loop. This will populate the entire matrix with edit distances. And then we want to get the value in the very bottom right to get the edit distance for the entire strings against each other. So I can just do that. That will return the very bottom right value of that array. And this is our edit distance function. So let's test this out. I'm going to start by running the edit distance recursive function. And we'll see how long that takes, and then we'll compare the time against our new dynamic programming version. So this line will just tell IPython to print out the time that it takes to run this. I'm going to say x equals, just give it two strings that are somewhat similar here. And then I'm going to calculate the recursive edit distance for x and y. And this is running. You can see it's already taking a bit longer than we would expect. These strings are only about 10 characters long. It takes about 5 seconds, and the edit distance is 3. You can see we have a upper and lowercase character here. We have a s matched up against a space here, and then or that would be an inserted space here, and then an inserted r here for an edit distance of 3. So now let's do the same thing, but use our dynamic programming version. So when I run this, it computes in about 200 microseconds, I think. So that's really fast.
That's better.
Edit distance is the same, so it works. So that's the dynamic programming version of edit distance.